So this is section 3.7 in your book, and it is a relatively short section based on solvation effects in acidity. So in your book, they give you an example that I won't repeat here, but I'll give you another one that we can talk a little bit about perhaps something like this. Okay, so these two molecules are fairly similar in that they both have an amine group, this nitrogen with two hydrogens here, and that amine group varies depending on how big it is, right? How much, how large the, or how many carbons are next to it. And as weird as it might sound, the amount of carbons that are around a molecule like this, like these two molecules, they have a small impact on the acidity that we might see. For instance, this one, this amine here, its acidity might be indicated by a pKa of around 28 or something like that, maybe 25. I don't remember the exact number, but the other one would have a pKa perhaps of around 27, 28, something like that. And the reason why is because whenever you go to solvate these molecules and create the charged state that is responsible for or the charged conjugate base, so we're talking about this reaction. You have some base, you take a proton to make this, more solvent molecules can be around to stabilize that conjugate base. And the number of solvent molecules depends on kind of how large the molecule is. So if the molecule is small like this, more solvent can be around, but if the molecule is larger, then there can be less solvent, which actually makes the conjugate base less stable and makes the molecule less acidic. That's kind of it. The larger molecules can be solvated less easily, and that means that the conjugate base is a higher energy. And that's section 3.7.